Today, we're taking a hard look at the current standard for retrieval-augmented generation. We're going to challenge it, actually. We'll dive into why the very foundation of most RAG systems is, frankly, a bit flawed, and then uncover a much more powerful, structurally aware way forward.
Everything really comes down to this one word, lossy. The foundation of pretty much all modern RAG systems, these vector embeddings, they're inherently lossy. And what that means is, in the process of creating these incredible semantic search capabilities, we are actively, purposefully stripping away the very structure that gives our data its context and its real meaning. And this slide, this really sets up the core conflict, doesn't it? On one hand, you've got the semantic vibe, the general feeling or concept that vector search is amazing at finding. But on the other side, you have hard structural facts, the explicit concrete relationships inside your data. The battle between these two ideas is what we're really digging into today.
So first things first, let's give credit where it's due. The state-of-the-art right now, the dominant architecture, is retrieval-augmented generation, and it's almost always powered by semantic vector search. And you know what? It's incredibly powerful, and for some very good reasons. I mean, RAG basically solves a massive problem for large language models, right? Instead of just relying on their static, often outdated training data, it lets them reach out, grab external, up-to-date knowledge, and use that to ground their responses in verifiable facts before they ever write a single word.
And it's no wonder RAG took over the world. It makes things more accurate, it keeps the knowledge fresh, it makes the answers explainable, and it's super adaptable. These are huge, huge wins. But they've been hiding a pretty fundamental weakness this whole time.
And that brings us to the other side of the coin. There is a real price to pay for relying only on vector embeddings. There's a foundational vulnerability here that can seriously impact the reliability and especially the scalability of our AI systems. This quote just nails it. Semantic similarity is not the same thing as relevance. A vector embedding can find a document that feels conceptually similar to your query, but that gives you zero guarantee that it actually contains the precise, factual answer you were looking for.
So here's the critical thing to understand. When we turn our documents into vectors, we're not just compressing them. We are actively throwing away their most valuable context. We're literally discarding hierarchies. The relationship between a main heading and all its subsections, the logical flow of an argument from one chapter to the next, all of that just gets flattened into a bunch of disconnected chunks of text. Hyperlinks. These are explicit, deliberate connections that the author put there for a reason, to signal that two pieces of information are related. Standard RAG, it just ignores them completely. And references. We're talking about citations, footnotes, bibliographies, the very things that prove where information came from and add depth. They get ripped from their original context and just become more random text inside a chunk. And finally, we lose all this incredibly valuable metadata. Things like publication dates, authors, section titles, compliance info. All this rich, filterable context just gets left on the cutting room floor.
And look, this isn't just some academic theory. The data proves it. Research shows that as you scale up your vector database, your RAG performance gets significantly worse. We're talking a 10 to 12% drop in accuracy for every 100,000 documents you add. All that new information starts to just become noise that drowns out the signal. And here is a perfect example of the real-world consequence. Because the system has no map of the document, no idea how the pieces fit together, it can't see the whole picture. This is exactly why standard RAG is so bad at summarizing an entire document. It's just trying to reassemble a puzzle without the picture on the box. Which, of course, leads us to the million-dollar question. If our entire method is built on the idea of throwing away our most valuable context, how on earth do we ever get it back? Well, the answer is a total shift in thinking. The secret isn't trying to recover what's lost. The secret is to build a system that never throws it away to begin with. And that is the core idea behind GraphRAG. So, instead of a flat, disconnected index of vector chunks, GraphRAG sees your knowledge base for what it really is, a complex network of interconnected ideas. It builds a structured map of your information, carefully preserving all those explicit relationships that vectorization just throws in the trash. So how does it work? Well, the nodes in the graph can still be our familiar semantic chunks. That part's great. But the game changer is the edges. The edges represent the actual relationships between those chunks. An edge might be a hyperlink or a citation or the simple fact that this section belongs under that heading.
That structure is now a core part of the system, not something we ignore. And because of that, the whole retrieval process is completely different. First, it finds a good entry point in the graph based on your query. But then, and this is the key, instead of just looking for similar stuff, it actually explores the graph. It follows the edges, the real connections, from one node to the next. This allows it to gather this incredibly rich, structured context from a whole neighborhood of related information before it even thinks about synthesizing an answer. It has an understanding that simple vector search could never, ever achieve. So what you have to realize is that this isn't just some new, clever technique. This is a fundamental shift in how we need to think about our data in the first place.
This quote just says it all, doesn't it? Our unstructured data is actually filled with structure, both explicit and implicit. The future isn't about flattening that structure away. It's about leveraging it as our most powerful asset for finding real answers.
And this all leads to a hybrid approach that really gives us the best of both worlds. We can keep using vector search for that broad semantic discovery, but we supercharge it with the precision of graph traversal. What you get is more comprehensive context, and you ground the LLM in a verifiable knowledge structure, which dramatically improves reliability and reduces those dreaded hallucinations.
So I'll just leave you with this one final question to think about. Every single one of your documents, every data set you have has structure built into it. The hyperlinks, the metadata, the hierarchies, it's already there. The only question is, in this new age of AI, are you building systems that actually use that structure, or are you just throwing it all away?